Hello everyone. Today we shall discuss class 12, that is chapter 1, electric charges and fields. This is chapter 1. Chapter 1, electric charges and field. Electric charges, electric charges and fields. Electric charges and field. First of all, we will learn how the charges arises, right? Electric charges and fields. Now, in any matter, when it is electrically neutral, what happens in that case? You find that all of us have an experience of seeing a spark or hearing a crackle when we take off our synthetic clothes or sweater, particularly in dry weather. Have you ever tried to find an explanation for this phenomena? Another common example of electric discharge is the lightning that we see in the sky during thunderstorm. Was experienced a sensation of an electric shock either while opening the door of a car or holding the iron bar of a bus after sliding from our seat. The reason for these experiences is discharge of electric charges through our body, which are accumulated due to rubbing of insulating surfaces. You might have also heard that this is due to generation of static electricity. This is precisely the topic we are going to discuss in this and the next chapter. Static means anything that does not move or change with time. Electrostatic deals with the study of forces, fields, potentials arising from static charges. What is electrostatics? Electrostatics means charges at rest. That is important. Electrostatics. Electrostatics. Electrostatics means charges at rest. Charges at rest position. Charges at rest. And electrostatic deals with the study of forces, deals with forces, fields and potentials. Fields, and number 3 is potentials. Potentials arising from static charges. Now we learn about electric charge. What is that? Electric charge. For that we are explaining about some experiment. Suppose there is a glass rod. Here there is a glass rod. This is the glass rod. And here there is another glass rod. If we rub this glass rod with wool or silk, it is found that this glass rod is changed into positively charged rod. Both the glass rod, it has been charged with plus rod. What is plus? Because when we are rubbing the glass rod with wool or silk, some electrons transferred to the wool or silk. When electrons are transferred, then glass rod becomes positive, right? And here is also same thing, glass rod. So here positive and positive, you have experiences that positive, they have a repelling factor or repelling nature. When a glass rod, this glass rod repels this glass rod. Why? The reason is that like charges repel each other. These are like charges. Like charges repel each other. Like charges repel each other. And if we take the plastic, suppose we are taking a plastic, okay, We are taking two plastic rods. This is a plastic rod. Plastic rods. Again, you have taken another plastic rod here. Plastic rod. And if we rub with cat's fur, you know cat's fur, if we rub with cat's fur, this plastic rod will change into negative. Here also you see the plastic rod gains negatively charged particles when we rub with cat's fur. So here also you find that these plastic rods, since both are negative, they will repelling each other. So we can say that like charges repel each other. But if we take this glass rod, positive, if we take this glass rod and this plastic rod together, this is minus, we find there is a plastic rod, we are finding that there is a attraction. Here it is attraction, not repelling. From this experiment, you can say that like charges repel each other and unlike charges attract each other. Unlike charges attract each other. Attract each other. Unlike charges attract each other. So this is the fact. What we are getting, that if we rub a glass rod with wood or steel, it becomes positive, and if we rub a plastic rod with cat's fur, it becomes negative. And when both are positive, it will repel each other. Here the plastic rod also repel each other. But if we take this glass rod and take this plastic rod and they become closer to them, then there is a force of attraction. So from this experiment, we can say that like charges repel each other and unlike charges attract each other. What happens in this? Why it is positive? Actually, if we say in this way, that suppose there are actually in a matter is electrically neutral. Any matter, suppose this glass rod, it is electrically neutral. In the previous case, electrically neutral. What is the meaning? Neutral means there is no charge, neither positive neither negative charge. Why is like that? Because the number of protons and number of electrons, number of protons equal to number of electrons in the glass rod, number of electrons. So you know that the charge for a proton, is plus 1.6 into 10 to the power minus 19 coulomb. This is the charge of a proton. And the charge of an electron is minus 1.6 into 10 to the power minus 19 coulomb. So the total charge in the glass rod is 0. But when you rub it with wood or silk, some electrons from glass rod comes to wood. So here the number of proton is greater. Since the number of proton is greater, here you see there is a positive charge. The same way, in the case of plastic rod also, if we rub with cat's fur, some electrons from cat's fur goes to the plastic rod. So the number of electrons increases in this plastic rod, and here there is a negative charge. So positive charge means loss of electrons and negative charge means gain of electron. In this way, we can say that electrical charge arises. So this is the process by which if the number of protons and electrons are same, it is electrically neutral. But if there is a difference between them, if there is a deficient of electron, it will be positive charge, and if any matter gains electron, it is a negative charge. That is our. So what we learn from this experiment, that like charges repel each other and unlike charges attract each other. In the next phase, we will learn about conductors and insulators. What are conductors and insulators? Conductors and insulators. What is the conductors and insulators? Conductors, some substances readily allow passage of electricity through them, others do not. Those which allow electricity to pass through them easily are called conductors. So those materials through which electricity can pass through easily are known as conductors. And they have electric charges, electrons, that are comparatively free to move inside the material. Actually, they have a free electron, right? Metal, what are the examples? Metals are conductors. All the metals are conductors. Human and animal bodies, human body, animal body, these are conductors. Human body, animal body, these are conductors. And earth, also remember that earth is also a conductor. Earth are conductors. And there are non-metals. What is that? Insulators. Insulators are those material which do not allow electricity to pass through them. So the insulators, examples of insulators can be like non-metals, like glass, this is an insulator. Or you can say it as a plastic is an insulator. Or you can say it as wood, they are insulators. They are insulators, right? Or you can say nylon. These are all insulators. These materials does not allow electricity to pass through them, so they are called as insulators. So there are two categories, conductors and insulators. Beside that, there is also a third category known as semiconductors. This is the first category, conductor. This is the second category, insulator, and third category is semiconductors. Semiconductor. So you can say what is that semiconductor. So there is a third category called semiconductors which offer resistance to the movement of charges, which is intermediate between conductors and insulators. There is a third category called semiconductors. Which offer resistance, which offer resistance to the movement of charges, to the movement of charges, which is a intermediate between the conductors and insulators. These are known as semiconductor insulators, right? Example, you can say it as, for example, germanium is a semiconductor. That there is a third category called semiconductor which offer resistance to the movement of charges, which is intermediate between the conductors and insulators, for example, germanium. So we have learnt about conductors, we have learnt about insulators, and learnt about semiconductor. The next important thing that we learn is the basic properties of electric charge. What are the basic properties of electric charge? Basic properties. We have three basic properties. Basic properties of electric charge. Basic properties of electric charge. What are the basic properties of electric charge? There are three basic properties. What we call it as additivity of charges. Additivity of charges. This is the first thing. Second thing is that charge is conserved. And the third point is about quantization of charge. So these are the important basic properties of electric charge. First one is additivity of charges. That means if a system contains n charges, q1, q2, q3 up to qn, the total charge of the system is you have to add. So if a system contains q1 and q2, q3 up to qn charges, then the total charge of the system, the total charge capital Q, if you add all the charges q1 plus q2 plus q3 up to qn, this is called the additivity of charges. Charge has magnitude but no direction, right? However, there is one difference between mass and charge, right? Similar to mass. Charge is similar to mass, but there is one difference. What is the difference? Mass cannot be negative, but charge can be negative. Charge can be either positive or negative, right? Proper signs have to be used while adding the charges in a system. For example, the total charge system containing the charges plus 1, plus 2, minus 3, plus 5, minus 5. So, if we add, suppose there are 3 charges, 1, plus 1, plus 2, plus 5. And the minus charges is minus 2, minus 3. Then we add all the charges. 1 plus 2 plus 5 minus 2 plus 3. So, getting the charges, we have to add it. 5 plus 2, 7, 8. 8 minus 5. The total charge is plus 3. So, this is the additivity of charges. That means you have to add all the charges, whether it is positive or negative. And the second one is charge conservation of charge. What is the meaning? We have already hinted to the fact that when bodies are charged by rubbing, there is transfer of electrons from one body to the other. No new charges are either created nor destroyed. Remember that charge is conserved. No new charges can be created or destroyed. When we rub two bodies, that one body gains in charge, the other body loses. Within an isolated system consisting of many charged bodies, due to interaction among the bodies, charges may get redistributed, but it is found that the total charge of the isolated system always constant. What is that? Charge conservation? That the total charge of the isolated system, total charge of the isolated system is always conserved. This is conservation of charge. Conservation of charge has been established experiment. It has been found by experiment that there is a conservation of charge. It is not possible to create or destroy net charge carried by any isolated system, although the charge carrying particles may be created or destroyed in a process. Sometimes nature creates charged particles. A neutron turns into a proton and electron. A neutron can be changed into a proton plus electron. A neutron can be changed into a proton and electron. The proton and electron thus created have equal and opposite charges, and the total charge is 0 before and after the creation. You see, the total charge of neutron is 0. And what is the charge of proton? It is plus 1.6 into 10 to the power minus 19 coulomb. And what is the charge of electron? It is minus 1.6 into 10 to the minus 19 coulomb. So the total charge is 0 here also. So you can see this is charge conservation, or the total charge of the isolated system is always conserved. That is, charge cannot be created nor destroyed. right? So what we can say that it is not possible to create or destroy net charge carried by any isolated system, although the charge carrying particles may be created or destroyed in a process. So this is known as conservation of charge. And the third important thing is quantization of charge. What is the meaning of quantization of charge? Experimentally, it is established that all free charges are integral multiples of a basic unit of charge denoted by E. Thus, the charge Q on a body is always given by Q is equal to N into E. Q equal to N. This is the quantity. What is the N? N is the integral integer. N is equal to integer. What is the integer? We know that integers are this one. If we draw a straight line, this is 0, 1, 2, 3, 4, 1, 2, 3, 4, and this one is minus 1, minus 2, minus 3, minus 4. So these are the integers. So these will be integral multiples of E, where n is any integer, positive or negative. The basic unit of charge is the charge of that of an electron or proton carries. So the charge of proton is, I already discussed that it is plus 1.6 into 10 to the power minus 19 coulomb, and that of electron is minus 1.6 into 10 to the power minus 19 coulomb. This is the charge of an electron. By convention, the charge of an electron is taken to be negative. Therefore, the charge of an electron is written minus C. We write sometimes we write minus C, and the charge on a proton is plus C. Right? The fact that electric charge is always an integral multiple of E is termed as quantization of charge. This is known as quantization of charge, because it is always integral multiple of either proton or electron. There are a large number of situations in physics where certain physical quantities are quantized. The quantization of charge was first suggested by experimental laws of electrolysis discovered by English experimentalist Faraday. It was experimentally demonstrated by Millikan in 1912. In the International System of Units, a unit of charge is called a coulomb and is denoted by the symbol C. Coulomb. A coulomb is defined in terms of the unit of the electric current, which you are going to learn in a subsequent chapter later on. In terms of this definition, 1 coulomb is a charge flowing through a wire in 1 second if current is 1 ampere. That is 1 coulomb, right? So the what is the value? The value of basic unit of charge is equal to 1.6 into 10 to the power minus 19 coulomb. Thus there are about how many electrons? So there are, you can say that F equal to Ne or N equal to Q by E. What is Q? Is 1 coulomb. And is the charge of electron 1.6 into 10 to the power minus 19. So the number of electrons is equal to 6.6 into 10 to the power 18 electrons in a charge of minus 1 coulomb. In a charge of 1 coulomb. In electrostatics, charges of this large magnitude are seldom encountered, and hence we use smaller units. We can also use 1 microcoulomb. This one, 1 microcoulomb. Microcoulomb is equal to 10 to the power minus 6 coulomb. 10 to the power minus 6 coulomb. And sometimes we use 1 millicoulomb, that is equal to 10 to the power minus 3 coulomb. These are the important things, right? So the protons and electrons are the only basic charges in the universe. All the observable charges have to be integral multiples of E. Thus, if a body contains n electrons and n1 electrons and n1 protons, the total amount of charge on the body is n2 into E plus n1 into minus E. This is the total charge, right? Since n1 and n2 are integers, the difference is also an integer. Thus, the charge on any body is always an integral multiple of E and can be increased or decreased also in steps of E. So this is the quantization of charge. The step size E is, however, very small, because at the macroscopic level we deal with the charges per few microcoulomb. At this scale, the fact that the charge of a body can increase or decrease in units of E is not visible. In this respect, the grainy nature of charge is lost and it appears to be continuous. So this is known as quantization of charge. So these are the basic properties of electric charge. One is additivity charges. We have to add in a system all the charges. That is additivity. What is charge conservation? Charge conservation is that in isolated system the total charge is conserved. Charge cannot be created nor destroyed, but the total charge is always same. What is quantization of charge? Quantization of charge means quantization of charge. What is that quantization of charge? Quantization of charge is that the charge on a body is always given by Q equal to n, where n is the integer and is the charge of an electron or a proton. If it is plus C, it is proton. If it is minus C, it is known as electron. This is charge quantization. That is, the integral multiple of electron proton is the total charge in a body. That is right. So what we get here, that beside that the unit of charge is coulomb, and we already defined, that is define the coulomb also. 1 coulomb is defined in terms of the unit of electric current. What is that? 1 coulomb is the charge going through 1 coulomb. This is the definition. 1 coulomb is the charge. 1 coulomb is the charge. 1 coulomb is the charge flowing through a wire. Flowing through a wire. Flowing through a wire of 1 second if the current is 1 ampere. This is the definition of 1 coulomb. 1 coulomb is the charge flowing through a wire of 1 second, where in 1 second if the current is 1 ampere. That is, and 1 microcoulomb will take to minus 6 coulomb, 1 millicoulomb will take to minus 3 coulomb. This you have to remember. Okay, so we have covered these basic properties of electric charge. What we learned here, that is how positive charge and negative charge arises, and that is due to transfer of electrons, right? And the next one is we learned about 3 types of that is, materials are divided into 3 types. One is conductors, insulators, and the third one is semiconductors. Conductors are those materials through which electricity can pass through them easily. That is conductors, like metals, human and animal bodies, earth are conductors. And what about insulators? Insulators are those which offer high resistance to the passage of electricity, and they are called insulators. That is nylon, that is glass, that is porcelain, that is plastic. These are insulators. Besides that, there are other type of category, that is semiconductors, which offer resistance to the movement of charges, which is intermediate between conductors and insulators, for example germanium, right? And the next one we have learned about the basic properties of electric charge, that is additivity of charges, charge is conserved, and quantization of charge. Okay, and the next video we next do the next thing, that is Coulomb's law. Thank you.